Hello, everybody. We are going to continue factoring today. We are going to learn our second factoring technique, which is called factoring by grouping. Let's take a look at an example. Let's factor x cubed minus 6x squared plus 3x minus 18. Now, so far, we've only learned how to factor by pulling out the GCF, the greatest common factor. Unfortunately, that's not going to help us in this problem, because if you look at x cubed and negative 18, those two terms don't have any factors in common. So there's no GCF that we can pull out. That doesn't mean that this can't be factored, though. What it means is that we have to learn a new method, and that method is called grouping. Here's what we're going to do. We're going to take the first two terms and put them in one group, and we're going to take the last two terms and we're going to put them in another group, and we're going to factor each group on its own. You'll see how this is going to help in just a minute. Let's take a look at the first group. What do x cubed and negative 6x squared have in common? Well, the GCF here is going to be x squared. That's the largest factor that both of those share. When we pull out the x squared, that leaves us with x in the first term, and then minus 6 in the second term. So when we factor the first group, we get x squared times x minus 6. Now let's look at the second group. If we look at 3x and negative 18, both of those are divisible by 3. So I'm going to put this plus here. I'm going to bring it down and then pull out the 3 as the GCF. What are the leftovers when we pull out 3? Well, 3x divided by 3 gives us x, and then minus 18 divided by 3 gives us 6. So when we factor this group, we get 3 times x minus 6. Now I want you to look at the two groups, the factorizations, and see if they have anything in common. What do both of those groups share? Well, both of them have a factor of x minus 6. So if we're looking at the whole thing, each of the groups has an x minus 6 in common. So x minus 6 becomes the greatest common factor of the groups. So we're going to pull x minus 6 out front, because we always put the GCF out front. And then in parentheses, we're going to put the leftovers. What's left over when we pull out the x minus 6? Well, there's an x squared and a positive 3. So the leftovers are going to be x squared plus 3. And I want you to notice now that we have a factored version. Instead of having one polynomial, we've written it as a product of smaller polynomials. So this is how factor by grouping works. If you want to check to make sure that you've done it correctly, you can do so by multiplying it out. Let's do that for one example. Let's FOIL this out to see what we get. If we multiply the first terms, x times x squared gives us x cubed. The outer terms, x times 3 gives us 3x. The inner terms, negative 6 times x squared is negative 6x squared. And the last terms, negative 6 times 13 is negative 18. And if we look at what we have here, the four terms that we have match the four terms of the original polynomial. They're in a different order, but that's okay. The order of the terms doesn't matter. We end up with the same polynomial that we started with, so we know that that works correctly. All right, we're going to do two more of these, and then I'm going to encourage you to look at some of the other worked out examples. Let's next factor 3x squared minus 12x minus 5x plus 20. Now again, there's no GCF here, so we're going to have to group them. and we're going to have to factor each group individually. If we look at the first group, the GCF is 3x. And then if we factor out a 3x, that leaves us with x minus 4 as leftovers. Now in the second group, we have to be careful. Let's look at negative 5x plus 20. Both of those contain a 5. However, if we just pull out a 5, then the leftovers are going to be negative x and positive 4. But what we want is a positive x and a negative 4. So what should we pull out instead of positive 5? We should pull out negative 5. We are allowed to factor out a negative GCF just as we factored out a positive GCF. When we pull out that negative 5, it leaves us with x for the first leftover. And then in the second term, 20 divided by negative 5 is going to be negative 4. So that gives us x minus 4 in the parentheses. And now we can see that the two groups have a factor in common, specifically x minus 4. So we can put that x minus 4 out front as the GCF. And then the leftovers are 3x minus 5. So we put those leftovers in parentheses. And our factored version of this polynomial is x minus 4 times 3x minus 5. Now there's one more thing I want to point out that we have to be careful with. Let's factor x squared plus 15 plus 3x plus 5x. Now, if we try to use grouping here, we're going to run into a problem. X squared and 15 only have 1 in common. And if we pull that out, we're left with x squared plus 15. And then 3x plus 5x has x in common. And if we pull that out, we're left with 3 plus 5. And unfortunately, if we look at what we have inside the parentheses, they don't match up, which makes us sad. We need those two sets of parentheses to contain the exact same factors so that we can pull it out as a GCF. So that doesn't mean that we can't factor this. It just means that we have to do something differently. And what we're going to do is we're going to rearrange the terms to make it work out better. And generally, the best way to do that is to put it in standard form. So that x squared is going to come first. Then the x terms are going to come next. And the order doesn't actually matter. Plus 3x plus 5x. The constant term goes at the end. And once we've done this, we now are in a place where grouping's going to work. If we put these into groups and factor the first group, the GCF is x, leaving us with x plus 3 in parentheses. In the second group, the GCF is 5, leaving x plus 3 in parentheses. And now we're happy because we have a GCF among the groups of x plus 3. And then the leftovers are x plus 5. And we are good to go. These are just 3 examples of problems that can be factored by grouping. I want you to look at those linked videos because there are a lot of other examples with more than one variable, with larger exponents. You're really not covering anything if you've just watched this video. You need to go through the rest of them to get an idea of the variety of scenarios that you can find yourself in.